Alright, so here we go. Part 2 of this two-part series on risk and return. In part 1, we talked about what expected return and standard deviation even mean. So here in part 2, I wanted to get into some more of the quantitative nature behind these two things. Because this section of any finance class is very, very quantitative in nature. And so my goal, my objective, is to bring you guys up to speed on how to perform basic expected return and standard deviation calculations. Okay, so let's go ahead and get started. The most common way to calculate expected return and standard deviation is through what is called a states of nature table. So in part 1, we talked about how you have certain predictions about next year. You have certain expectations about the various outcomes that could transpire next year. That is where a states of nature table comes into play. Now, this word nature can take on various forms. You could be looking at sales, you could be looking at GDP, you could be looking at unemployment, you could be looking at interest rates, you could be looking at just the overall economy as a whole. So it's extremely broad defined, and rightfully so, because it's going to depend on the context that you're in that's going to drive specifically what type of quote-unquote nature you want to use. But the most common application of a states of nature table is going to be states of the economy. So that's kind of how we're going to get started. So let's say that you determine that next year the economy could be in one of three possible states. It could be in a boom, it could be in an average state, and it could be in a recessionary state. Now, I'm going to spend a lot of time in 680 talking about how you would arrive at these figures, and you guys have a project actually that you have to do centered around that, so I'm not going to go through that here today. You might be wondering, well, how would you even figure that out? Don't worry, we've got a lengthy discussion prepared for you guys. Same thing with the probabilities of those states occurring and how you determine those numbers. For right now, let's just focus on the strict mechanics. Okay, so you determine that the probability of a boom state occurring is 35%, average is 40, and recession is 25. Okay, so let's say that you're trying to analyze Chipotle stock. The ticker symbol for Chipotle is CMG. A ticker symbol is nothing more than an abbreviation to more easily follow a stock on the exchanges and follow, its price, its yield, its volume, all those kind of things. So let's say that you want to determine, hey, what is the expected return and standard deviation of Chipotle? Well, let's say that if we are in a boom state, Chipotle is going to earn 46%, and this is a stock return. So this is the R from the previous section on stock valuation basics. So this is essentially the combination of what you can earn in Chipotle from both the dividend yield and capital gains yield. Let's say that if things are average, it'll be 11%, and if it's a recession, Chipotle is going to lose 37%. Okay, so with all those things in place, how do you calculate the expected return and the standard deviation? All right, the expected return calculation. This is actually very, very straightforward. All you have to do is take a weighted average of the probabilities and the returns across all the states that are in the table. So what does that actually mean? Well, it means that the expected return is equal to the probability of the first state occurring times the return of the first state occurring, plus the probability of the second state occurring times the return of the second state occurring, plus the probability of the third state occurring times the return from the third state occurring. Now, the reason why I have ... PNRN, basically you just keep going until you run out of states. So N here represents the total number of states you have in your table. So for example, if you had 5 states, you would just have 5 terms here, right? P1R1, P2R2, P3R3, P4R4, and P5R5. So it just keeps going on until you've exhausted your N, until you've exhausted the number of states in your table. So here's what the actual numbers look like pulled from the table. So the probability of the first state occurring is 35%, the return from the first state occurring is 46%. And then 40%, 11%, 25%, and minus 37%, which works out to a total expected return of 11.25%. And there's all kind of the intermediate steps. The only point that I want to make for you guys, if math is not your strongest area, and if you're kind of dreading, Finance 680 because of the math requirements and all those kind of things, let me make your life a little bit easier. Here's a recommendation that I make for you, and I think everybody should do this, even if your math skills are strong. It just makes things so much easier. When you have a states of nature table, when you're doing expected return or standard deviation, just put everything in as a decimal. Do not put anything in as a percent. So 35%, don't put 35 there, put 0.35. If you put all your percentage numbers in as decimals, whether they be a return or whether they be a probability or a return, you will never get the wrong answer. You will always be on track. Well, you'll never get the wrong answer from a math error standpoint. You may get the wrong answer if you set it up incorrectly. But just strictly from a math, multiplication, functionality standpoint, this will keep you on point. Okay, so that's how you solve for the expected return. Now, let's scroll down a little bit. How do you find the standard deviation? This is a little bit more involved. And this is going to differ from how you traditionally find standard deviations in a statistics class. Because in a statistics class, the assumption is each state has an equal likelihood of occurring. Well, we clearly see that that is not true. So what we need to do is what is called a probability-based standard deviation equation. Now, rather than put up a big scary formula with standard deviation, well, I'll probably do that stuff in Finance 680, I kind of wanted to break it down into chunks to make things a lot easier for you guys and make things more manageable, especially if you guys haven't seen this stuff in a while. I think this is a much easier, more applicable way to learn probability-based standard deviations. And you can save these notes, right? You can use these notes in Finance 680 and they will still work. They will always work. Okay, so what do you need to do? You need to follow these 5 steps, and I'm going to explain these 5 steps down here with the numbers. You need to follow these 5 steps, and then you're all set. All you need to know is this. You need to complete steps 1, 2, and 3 for each state before you proceed to step 4. Once you've exhausted all of your states, then you do step 4, then you do step 5. So what does that actually look like? All right, so let's just focus on this first line right here. Okay, what you see in the parentheses, so this guy right here, that is step 1. That is my deviation from the mean or average for that state. My return from the first state was 46%. I'm just moving top down, first state being boom. It doesn't matter which order you go in, top down, bottom up, whatever you want to do. The return from the first state was 46%. There it is, 0.46. My mean return or average return or expected return, all the same thing in this context, was 11.25%. So there's that guy. Okay, so that's the first step. What is the second step? Square that deviation. That's this guy right here. All you do is square that deviation. What's the third step? Multiply by the probability of that state occurring. That's this guy right here. Take all these guys together and you get this number right here. 0.04226. You definitely want to make sure that you go out to like 4 or 5 decimals on your calculator because your numbers can get really small here, and if you only go out to 2 decimals, it can be you can lose quite a bit to rounding. If you have the text, really quickly, if you have the Texas Instruments BA2+, to reset your decimals, just press second, then press the decimal key, which is on the bottom. On the screen, it'll say DEC equals. Just key in the number 5, for example, and then on the top row, press the enter key, and then you'll see your decimals will reset for you to 5 decimals. So this is the first 3 steps for the first state. So I'm done. I move on to the second state. Same process. There's step 1, there's step 2, there's step 3. That's a very small number. In fact, that number is nothing out to the 5th decimal. It is 0. And then here is the first 3 steps for the third state or the recession state. Now, once you have these numbers in place, I can't highlight it vertically. Once you have, there probably is a way to do it, but I don't really feel like figuring it out. Once you have these numbers in place, you can now proceed to step 4. You sum your results. The results are these 3 numbers right here. So my sum of those numbers is this guy right here. Then you move to step 5, and you take the square root of the sum, which is 31.7%. Okay? Now, again, what does this number mean? Well, here's all I want you guys to recognize right now. That number gives you some indication of how wide or how narrow your fluctuations around this expected return are going to be. I'll have a lot more to say about that in Finance 680, but right now just understand this. Higher standard deviation means greater fluctuations. Lower standard deviation means tighter fluctuations. So that's it. We'll wrap up the two-part series on risk and return right there.